I have to wonder how much have we actually learned about AI that we didn't know before? I keep reading new material, but it's always interesting to see how much our perceptions have shifted.
I love that you brought this up. It's wild. Just a month ago, I wasn't even sure what artificial intelligence truly meant. Now I find myself noticing it all around me. And honestly, my feelings about it are a lot more nuanced than before.
Exactly, and you're not alone. I've seen a lot of hands go up when I ask if anyone's changed their mind about AI since starting. The thing is, we all come in with certain expectations, and then a bit of shock or awe hits as we see what AI actually is and isn't.
That's true. And what surprises me is how many misconceptions we all seem to carry. There's so much hype and mystery about AI, but when you peel it back, it's actually a story that started long before most of us were born.
You mentioning origins reminds me people often talk about AI as if it just appeared out of thin air, but the drive to build thinking machines has been with us for ages. Movies, books, daydreams, you name it.
Oh, totally. Even ancient myths have mechanical beings. There's something deeply human about wanting to make machines that can think or learn. But it didn't really start moving until we had the right blend of math and computing power.
That combo was a game changer. Before that, the idea was mostly science fiction. But once people could actually start translating thoughts into mechanical processes automation, in other words, AI started to become a real discipline.
And it's funny people still forget that what we call AI today is built on decades of slow progress, false starts, and plenty of detours. There's a real story behind it all.
Let's dig into one of those building blocks, mathematics. Folks usually think math just means calculus, but AI uses a whole arsenal: algebra, probability, statistics, logic. It's a real toolkit.
Yeah, I used to picture math as this wall of formulas. But in AI, each branch has a purpose. Like, probability helps AI make predictions, while algebra and matrices let computers process images and data.
Exactly. And I always find it wild that the images on your screen are basically just giant matrices. Each pixel is a number, and AI processes those using linear algebra.
Plus, calculus comes in when we talk about learning, like with gradient descent, where AI models adjust themselves to get better. It's the math working quietly behind the scenes.
Speaking of the basics, logic and binary are literally the language computers speak. It's always zeros and ones with rules like and, or, and not. Simple, but so powerful.
What gets me is how this basic logic forms the backbone of both computing and AI. If you think about it, even complex AI decisions boil down to chains of logical steps, just dressed up in a lot more layers.
And that's where symbolic reasoning fits in too, right? In early AI, it was all about encoding logical rules and letting the machine follow them.
Totally. It reminds me of those if-then statements we all learned in programming, except scaled up to handle massive, complex problems.
Let's not forget how calculus and probability shape AI's learning process. Calculus is all about finding the rate of change, so models can minimize errors and learn over time.
That's so true. When people talk about neural networks adjusting themselves, it's all those derivatives and gradients at work. And then probability steps in for real-world questions like, what are the chances this image is a dog?
It's actually pretty cool how these abstract math ideas become so practical. Without them, we wouldn't have AI that can spot cancer in a scan or power voice assistants.
And let's not sleep on statistics or discrete math sampling, optimization, data storage. They're essential for everything from databases to sound recording.
Switching gears a bit, it's fascinating how hardware and software have started to split off as separate worlds. Quantum computers, for example, are all about new hardware, while cloud computing is a software game changer.
That's a perspective I hadn't really thought about. The fact that you can now rent supercomputer power from the cloud, rather than needing a room full of machines, really changes what's possible for AI projects.
And quantum computing is so wild, using near absolute zero temperatures and ditching traditional transistors. It's like we've entered a new era where the physical stuff and the code are evolving on their own tracks.
Right, and it means AI isn't limited by your laptop anymore. It's a team effort between hardware innovations and smarter software.
All this groundwork sets the stage for one of my favorite pieces of AI history, the Dartmouth Workshop in 1956. It's basically where AI as a field really began to take shape.
I love those stories. So, John McCarthy, a mathematician, got a bunch of people from different backgrounds together, engineers, computer scientists, psychologists, to hash out what AI could become.
Exactly. And that interdisciplinary vibe was so important. If you look at the workshop's participants, Claude Shannon, Nathaniel Rochester, they each brought something different to the table.
Plus, there was a practical side to all this. They needed funding and recognition, so coining artificial intelligence as a name was also a smart move to attract attention and investment.
Let's talk about those pioneers for a second. John McCarthy was the guy who actually created the term artificial intelligence. Then you had Claude Shannon, who's often called the father of information theory.
I read a bit about Shannon. He was both a mathematician and an electrical engineer. His work on information theory literally changed everything about how we store and move data.
And Nathaniel Rochester, the IBM engineer, was all about making computers practical for business. He even worked on some of the earliest AI programs.
It's amazing how those early collaborations set the tone for AI's progress, different minds coming together to solve really big, messy problems.
That workshop was ambitious. They wanted to simulate every aspect of learning and intelligence, even though computer hardware back then was so limited. Talk about dreaming big.
It's kind of inspiring, though. They had all this optimism, but also some wishful thinking. Funding was tough to come by, and the Rockefeller Foundation actually rejected them at first.
But their persistence paid off. Once the funding came through, they pushed ahead, laying the groundwork for the field. It's a reminder. Big breakthroughs often start with a group of stubborn optimists.
And it shows how important collaboration and vision are. Sometimes you have to sell people on what times could times be, even when the pieces aren't quite there yet.
Now, one thing that came out of that workshop was the struggle to pin down clear definitions, especially for words like intelligence. Voltaire, the French philosopher, said you have to define your terms before you can really communicate.
That idea really sticks with me. Marvin Minsky, one of the AI founders, called intelligence a suitcase word. It's packed with meanings. And unless we're specific, things get confusing fast.
That's so true. If we say AI understands language, what does that mean? For humans, it's comprehension. For AI, maybe it's just pattern recognition. If we're not precise, we fall into hype or misunderstand what AI can actually do.
Exactly. That's how tech bubbles happen. People get excited about ideas without clear definitions, and suddenly everyone's investing in things they don't really understand.
So, having precise definitions isn't just academic, it's crucial for making real progress and setting realistic expectations. Otherwise, we risk overestimating what AI can do and missing its actual limits.
That reminds me of the dot-com bubble. Everyone piled into tech companies without really grasping what the technology could deliver. In AI, the same thing happens if we're not careful with our terms, like calling any pattern-matching system intelligent.
It's a good reality check. We have to watch out for overusing buzzwords like understanding or thinking without backing them up with clear meaning.
And as AI keeps evolving, new suitcase words keep popping up. So it's on us as learners, and eventually as users, to keep those definitions sharp.
Let's zoom in on the definition that came out of the Dartmouth meeting. Synthesizing intelligence, lacking strict boundaries, and enabling innovation. What do we actually mean by synthesizing intelligence?
I'd say synthesis is about building something new out of different parts, like combining math, data, and computing power to create behaviors that look intelligent. But we have to be clear, it's artificial. It's not human intelligence, it just imitates certain aspects.
Right. For me, intelligence in AI boils down to problem-solving, learning, and decision-making. That's the engineer's perspective anyway. But there's still debate on what counts as real intelligence.
And that debate keeps the field moving. As long as we're honest about what AI is doing, creating artificial versions of intelligent behavior, we can build better systems and avoid those endless arguments.
Now, what about that lack of strict boundaries in AI? It's both a blessing and a curse. Some say AI is anything that mimics human thinking, while others focus on systems that just do tasks requiring intelligence.
That's the beauty of a new field, honestly. It grows by being open-ended. So we get everything from robotics to language processing bundled under the same umbrella. But the downside is confusion if we aren't explicit about which definition we're using.
Yeah, every discipline wants a piece of AI, which keeps things exciting, but it means we all have to be clear when we talk about what AI is, especially in research or policy.
And that openness is why AI keeps expanding into new fields, sometimes in ways nobody expected just a decade ago.
The flexibility in defining AI is what's fueled so much innovation, new algorithms, tools, and even entire industries. But it's also opened up fresh ethical challenges, like bias and accountability.
No kidding. It's easy to get swept up in the excitement and forget that AI can reinforce biases or make decisions we can't easily trace back. That toolbox analogy is spot on. We just keep adding new tools, but we need to check what we're building with them.
Exactly. And as AI spreads into fields like healthcare, business, or even art, we have to get serious about fairness and transparency. Otherwise, the innovation that makes AI powerful could also make it risky.
So, the bottom line, AI is synthetic, open-ended, and full of possibilities, but it's up to us to set the boundaries and think critically as the technology grows.
Before we break, let's touch on where the real fireworks started, the split between symbolic and subsymbolic AI. That debate basically turned the field upside down.
It really did. Early on, the argument was over whether we should try to explicitly program intelligence using logical rules and math, or let machines learn from data, more like how humans do intuitively.
Some folks, like my old advisor, were diehard fans of writing out every step mathematically. Others were starting to experiment with neural networks and letting models discover patterns without explicit instructions.
Those clashing viewpoints led to major breakthroughs, but also some serious bumps in the road, like the infamous AI winter when hype fizzled out and funding dried up. But that's a story for another podcast.